Hello students, today we are going to study class 11th Applied Mathematics. This is a new application based subject introduced by CBSE. As many students are facing problem in studying it, so I decided to make some videos to help students. So what we are waiting for? Come on, let's start. Today we will be studying chapter number 2, Indices and Logarithms. I have started this chapter because some topics you have already studied in your previous classes. So let us start this. First we will be doing the introduction part. As you are already know that if I am writing a power n, it means that a is multiplied n times. So here the same, that is here a power n. In this we call a as base and this power is known as the exponent, or sometimes we call it as index. The plural of index is known as indices, based on which we have the name of our first part of the chapter, indices. And whenever we are writing it in the form of a power n, it is known as the exponential form. Next topic is fractional indices, or we call it as surds. Here, for example, if I am writing cube root of 8, we know that the cube root of 8 is 2. Why? Because we know that cube of 2 is equals to 8. Or let us take another example. If I am writing fifth root of 243, we know that this is equals to 3. Why it is so? Because 3 power 5 is equal to 243. Here the symbol of this under root, we call it as radical sign. After this we have certain laws for real numbers which is applicable on indices also, which you have already studied in your previous class. So let us recall. The first is a power m into a power n is equals to a power m plus n. It means when the bases are same but the powers are different, then their powers gets added. Second law, a power m bracket power n. It means that then the powers here are multiplied here, because the bracket means multiplication. Third law, a power m upon a power n. As the bases are same but they are in division, then their powers will get subtracted with the same common base a. Fourth law, a power m and b power m. Students, please note here the bases are different but the powers are same. In that case we can take their power as common. That means I can take AB as together as they are in multiplication, and the powers can be taken as common. Next we have a upon b power m. It means this can also be written as a power m upon a power m. Next one, a power minus n. It means that 1 upon a power n. Whenever we have minus in the power, our always target is to remove the negative sign. So in that case we can take the reciprocal of whatever the base is given to us. Now the seventh law, a power n equals to b power n, where the special condition is given to you, n not equal to 0. That means this power n should not be equal to 0. Why it is not equal to 0? Because if n will be equal to 0, then we know that any number power to 0 is always equals to 1. Then this is automatically will be equal. But we are not including this condition. So in that case a is equals to b. Next is whenever we have a power m equals to a power n, means the bases are same, then we can compare their powers. Students will be doing based questions on this soon. This is m is equals to n. Let us start with some examples. First example is given to us that 256 power minus 4 power minus 3 by 2. As the power is written in very small, so first I am solving this power separately here for you so that you can understand easily. So this is the power minus 4 minus 3 by 2. Minus 4 can be written as minus outside 2 power square minus 3 by 2. Here, as we have studied now in our laws, when these are in brackets, so it means power gets multiplied. 2 into minus 3 by 2, so 2 and 2 get cancelled. We have minus 2 power minus 3, and whenever we have in negative sign, it goes in denominator according to our law. So this becomes minus 1 upon 2 cube, and finally the cube of 2 is 1 upon 8. So after solving this power, we directly come to this step. That means we got 256 power minus 1 upon 8. Now 256 can also be written as 2 power 8, because if we multiply 2 8 times, then we'll be getting as 256. Now again 8 and 1 upon minus 8 are in multiplication. So here we have written this way, and from here that 8 and 8 get cancelled. This get cancelled, and we are only left with 2 power minus 1, and 2 power minus 1 is equals to 1 upon 2, which is the answer of our question. Start with the second example, which is 4th root of 28 divided by cube root of 7. So let us solve this. Now how we can solve it here? As 4th root of 28 can be written as 28 power 1 by 4, and cube root of 7 can be written as 7 power 1 by 3. For solving these types of questions, first we have to make their powers same so that we can take common. For that, whatever is given in the denominator of the power, will be taking LCM of that. So LCM of 4 and 3 is 12. So now for each of the number, we'll write the exponent in 12. How we can prove that? Let us see. 28 power 1 by 4 can be written as 28 cube into 1 by 12, because when we cancel, if we cancel 2 and 12, this will make 1 upon 4, which is same as that of our question. So by doing this, we are not making any change in our question. Similarly, we'll be doing for the 7 power 1 by 3. So this can be written as 7 power 4 into 1 by 12. Again here 4 and 12 can cancel, and this is 1 by 3. So again we are not making any change in our question. Now let us solve this. As these are in divided, so we can write in the form of numerator and denominator. From both of this, I can take 1 by 12 as common, because 1 by 12 and 1 by 12 are same here. Now 28 cube can be written as 28 3 times, and 7 power 4 can be written as 7 4 times, and we can cancel it here. That is, here 7 4s are 28, 7 4s are 28, and here also 7 4s are 28. So we are left with 4 into 4 into 4, and in denominator with only 7. So this become 4 4s are 16, 16 4s are 64 upon 7 power 1 by 12, or this can be also written in this form. This is our final answer. One more example based on this. The example is 5 power n plus 2 minus 6 into 5 power n plus 1 upon 13 into 5 power n minus 2 into 5 power n plus 1. As now the powers are in addition, so by the laws of exponents, it means that this can be written in the form of products. So let us see how we can write. Here 5 power n plus 2 can be written as 5 power n into 5 square. Similarly, for this 5n plus 1, 6 as it is, and 5n plus 1 can be written as 5n into 5 power 1. Similarly, for denominator also, 13 written as it is, 5n as it is, so we'll keep it as it is because there is no addition or subtraction here. But in the second part, minus 7, 5n plus 1 can be written as 1 plus 5n. Now from this, if you observe that from this I can take 5n as common because 5n is in numerator as well as in denominator. So let us take 5n common here. So we are left with in numerator 5n square, that is this part. Then we are left with 6 and 5 power 1, this one. Similarly, from the denominator 13 as it is, and in denominator we are left with 2 into 5. Now let us solve. First 5n and 5n get cancelled here. So after that we are left with the simple calculation. 5 square is 25 minus 6 5s are 30. 13 minus 5 2s are 10. So our final answer is minus 5 upon 3. Hope students you like this concept and completely understood. I'll be coming back with some more concept of new topics from applied mathematics. Bye bye. We'll meet soon.